Okay, we're going to learn how to graph sine and cosine. And one thing I want to remind you of is that the ordered pairs on the unit circle are in the form of cosine, comma sine. Cosine is our x value, sine is our y value. And we're also going to be reminded of the unit circle, how we take a radius of 1 unit and we swing that around and we create this circle. So we have these ordered pairs, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And we're going to graph in radians. So we have 0 radians. Remember, this is 180 radians. Whoops, sorry. That's 180 degrees, which is pi radians. So this 90 degree up here is pi over 2. And if we were to count by pi over 2's, we'd be at 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, or 2 pi. So the first thing we're going to do is we're going to graph y equals sine theta. And I just want to ask you, is there any number that you could put in for theta on your calculator and not get a value? Like, is there any number you could do sine of that number and your calculator would give you an error? So maybe try a few. Like try sine of negative 20. Maybe try sine of 600. Maybe try the sine of 43. It's going to give you a value for any number you put in for theta. So the domain is all real numbers, or negative infinity to infinity. The range, though, if you were watching the numbers that you were getting for your answers, the range is only between negative 1 and 1. So as we graph this, I'm going to make a really long x-axis. And here's my y-axis. I'm only going to look on the y-axis between negative 1 and 1. But I'm going to take these special quadrant angles on the unit circle and I'm going to stretch them out because all the way around the unit circle, from 0 to 2 pi, we get all the sines values and then they start to repeat again. So we're just going to look at one period from 0 to 2 pi. And half of 2 pi to 0 would be pi. Half the distance from 0 to pi is pi over 2, and half of this distance is 3 pi over 2. So we're just putting these angles down, 0, pi over 2, pi, 3 pi over 2, and all the way back to 2 pi. All right, now if sine is y, then at 0, I want to know what's the sine's value. So I'm looking right here. At 0, what's the y's value? 0. At pi over 2, what's the y's value? 1. At pi, what's the y's value? 0. 3 pi over 2, y is negative 1. And at 2 pi, we're back to this one. We're back to 0. And sine is this nice rounded curve, like that. This is one period of sine. Sine actually goes on forever. If you've watched a lot of hospital dramas on TV and you've seen them talk about the sinus rhythm, it's something like that. And that's how it got its name. It's got a variation of that. Okie dokie. So that's how we'll sketch the sine curve. And we can make the cosine curve now. I might say y equals cosine x. I might say f of theta equals cosine theta. I might say y equals sine theta. cosine theta. So cosine is dealing with the same quadrants on the little circle, the same quadrant angles. Zero, pi over 2, pi, 3 pi over 2, and 2 pi. So we'll be ready to sketch it. Stretch the x-axis out. Cosine is also okay for all values of theta, so its domain is all real numbers. And its range, just like sine, is between -1 and 1. So if you tried a bunch of numbers on your calculator and you tried to take the cosine of them, every number you try would work, and all the answers would be between -1 and 1. So we're going to go ahead and set up our y-axis between -1 and 1. And we'll do the same numbers on the x-axis using our quadrant angles. Then, as we do the cosine of 0, we'll look at this ordered pair, and cosine is the x value. So the cosine of 0 is 1. Pi over 2, look at this ordered pair. Cosine is x, so it's 0. At pi, checking out that ordered pair, cosine is -1. 3 pi over 2, cosine is 0 again. And at 2 pi, we're back to the same ordered pair. We're back to 1 again. So cosine looks like that. That's one period of the cosine function. And the period of cosine is 2 pi. Ask questions, write down questions that you might want to ask me Thursday when we're together again. So just like the sine curve keeps on going forever, the cosine curve does too. And when you overlap the cosine curve and the sine curve, I don't know if I'll get this to work right. Yeah, I didn't get that to work right, but I'll just do it below it. The sine curve. You'll notice that these curves are the same. They're just shifted over, but they're the same curve. Okay. Now let's talk about amplitude. Definition of amplitude. It is half the distance between the maximum and the minimum values of the function. And how do you find it in a function? It's represented by a. When a is multiplied by the sine of x, that is our amplitude. So if you wanted to graph something, let's say we wanted to graph y equals 3 times the sine of x, you would immediately realize its amplitude is 3. So we said the amplitude was half the distance between the maximum and the minimum. You might just take your amplitude and mark it at 3 and mark it at -3. Here's the amplitude. So between the maximum and the minimum, let me do a larger bracket, that's 6. And so half of that distance is 3. But what it does is, instead of the sine function starting at 0, well, let's set up our x-axis. 2 pi, pi, 2 and 3 pi over 2. The sine of 0 was 0. And 3 times that is still 0. And then at pi over 2, the sine of pi over 2 was 1. But it actually goes all the way up to 3. Because 3 times that is 3. Sine of pi is pi 0. 3 times 0 is 0. Sine of 3 pi over 2 was negative 1. But multiplied by that amplitude of 3, it's down to negative 3. And it's back up to 0. So let me just add in what the parent function would look like. So the parent function for sine, it starts at 0, it hits its height, it's 0 again, hits the low part, back to 0. Now you can see how the amplitude changes. Ooh, that did so terrible. Now you can see how, oh, this is so terrible. Let me try again. There, 3rd time's the charm. Now you can see how the amplitude changed our graph. The red one was the original. And the black graph is the graph with the amplitude of 3. So how do you keep sine and cosine straight? I like to think sine starts at 0, hits its height, crosses 0 again, hits its depth, finishes at 0. When you first saw the word sine, or the abbreviation for sine, you probably thought sin, and sin entered the world through the serpent. I mean, that's not exactly right. Sin was, who caused the first person to sin? It was the serpent when he tempted Eve, and Eve allowed herself to be tempted. So I kind of make this little sine curve into this little slithery serpenty snake. And it doesn't look as much like a snake. It looks more like a seal. Normally it looks more like a snake when I do it. So I see the sine curve as looking like a snake. But the cosine curve, when you sketch it, it always starts high, crosses 0, hits its low point, crosses 0, and finishes high again. So that's what cosine looks like. That's how you can keep the two straight. Sine looks like the serpent. I think that's it for today. I'm going to give you a couple to practice. I think I have already posted them on Facts. If not, I will. I'd like for you to practice graphing these few. And then we'll work on problems during class on Thursday.